Problem 3, determine if each of the relationships are functions. So first let's recall the definition of a function. So for each input there must be exactly one output. So let's keep this definition here in mind as we work on parts A and B. So for part A, 1 goes to the output of 3. What about 2? 2 also goes to the output of 3. 5 goes to 5. 8 goes to 9, and 9 goes to 8. So here I have input, set of inputs, and here's a set of outputs. And each of these inputs can only go to one place. And you might be thinking, but 1 and 2 both go to 3. They do, but 1 only goes to 3, and 2 only goes to 3. So this is a function. What about part B? For part B, 1 goes to 3. And then 1 again goes to 4. 2 goes to 5. But then if you notice, 2 again goes to 6. And then 3 goes to 7. So these are the inputs, and these are the outputs. If you notice, our set of inputs here, 1 and 2 namely, have more than one output. In fact, 1 goes to 3 and goes to 4. 2 goes to 5 and 2 goes to 6. So we're not really certain what the output would be for an input of 1 because it has 2 options. Similarly, the input of 2 has 2 different options for an output, so we don't really know what it's going to lead to. So this is not a function. Visually, I hope you notice that these inputs can converge to the same output here, and that's still a function. But if you have an input that branches off to more than one output, then that's not a function. So not a function, they will branch out. If they are a function, they can converge in like this.